Okay, welcome to this demo on clipping raster data. Okay, so we've seen how to clip vector data. We need a different tool to clip raster data, and we are going to show how to implement that at a technical level in this demo. So let's talk a little bit about the data we have. So we have a land use raster from 2015, okay, for all of Ontario. Okay, so let's open that up. All right, so remember that our raster attribute tables are structured like this. We have different integers representing different, in this case, land use categories. Okay, we have the count of the number of cells, the number of raster cells in each, what we call zone. Okay, so we can select each zone, which is each row here, and that will select all the raster cells that are that same, in this case, land use type. So if we select 20, it'll take a while to select everything, but we will see that 20, in this case, represents freshwater. Okay, so all the Great Lakes light up, and we've selected those. Okay, and we have the metadata, and we can tell what all these other numbers mean. So we'll go ahead and deselect that and close out of this. We also have a vector layer here, representing the boundaries of Southern Ontario. Okay, and what we are actually going to see is that we can use this vector layer to clip, to cookie cut out our raster data. Okay, and our goal in this assignment is to extract the raster cells, the land use cells within a city boundary. Okay, so we have all these city boundaries, Kitchener-Waterloo, Cambridge, Guelph, so on and so forth, for Southern Ontario. And we have all this land use data for all of Ontario. But we want to create a data set file that is specifically about Guelph, so that when we do further analysis, we can get numbers that are specific to Guelph. Okay, so let's see how we do that. First things first, we know we need to select from this boundaries layer only Guelph. Okay, we only want to select the city of Guelph because that's the particular shape we want to use as our cookie cutter to extract all those land use cells. So as you can see, we've selected the outline of Guelph. Now, the next thing we need to do is find the raster clip tool. Okay, so again, it is not the same as we use for vectors. For the vector clip, we go to geoprocessing. For the raster clip, the easiest way to get it, I think, is to search for it. So if you aren't already aware, you can use the Windows menu, go to search, search menu pops up, and we can search for clip. Again, clip analysis is going to be what we use for clipping out vector data, whereas clip data management is what we can use for clipping out rasters, raster cells. Okay, so we will click on that. We are going to pick our input raster, which is of course the land use layer. Our output extent just means what are we clipping this with? And we want to select that layer, the boundaries layer. And a couple of other options here that we need to select. We are going to make sure to use our features for clipping geometry. So all this means is that we are going to use our vector layer here to clip our data, and we want to maintain the clipping extent. So we need to make sure that we do not want to create a square here. We want to match the shape of the city of Guelph. We want only the raster cells in that shape, the shape of the city's boundaries. So we will go ahead and approve this. Again, it's going to be showing us that it's doing its work down here. And there it will go. It will refresh. And now since it's just pulling up the same cells, and it has the same symbology. We can't actually, from this view, tell if it's worked. We need to turn off the Ontario-wide layer first. And we can tell that it has worked because when we turn off the Ontario-wide layer, we see that we have now created a new layer that is only for Guelph. We've clipped that raster to the city of Guelph, and we can zoom in. Okay, and we can actually go to the attribute table, and we can see there are only 16 kinds of land uses in the city boundaries, and we now know how many raster cells each land use accounts for. Okay, so for instance, we know that 20 represents fresh water. There are 331 raster cells representing fresh water. We can do the math to find out how much area that accounts for, because we know that each cell is 30 meters by 30 meters. That's the resolution of our raster data. And so there you have it. We have clipped our raster data to a specified shape, in this case, the outline of the city of Guelph.